Today we will be learning about adding and subtracting fractions with unlike denominators. We know from previous lessons that when we are adding fractions with like denominators, we are adding fractions that are cut into the same size pieces, which makes the process a little easier. If I'm looking at 1/5 plus 1/5, I know that I can just combine those two pieces and it will give me my answer of 2/5. However, when we're looking at fractions with unlike denominators, we have an extra step ahead of us. In this problem, we're adding the fraction 1/5 plus the fraction 1/3. When we look at the visual representation of this, we can see that they don't represent the same amount. Those pieces are not cut to the same size. And looking at this, you can tell that 1/5 is actually less than 1/3. If we try to bring the 1/5 over and sit it on top of the 1/3, we wouldn't really be able to tell for sure what the total was. We might be able to guess, but we wouldn't know for sure. Therefore, we have to change the denominators to make them like denominators because it's the only way we'll know the true total. Here, I have lined the fractions up vertically so we can begin the process of changing them into equivalent fractions that have the same denominator. And we're going to do that by finding the least common multiple for the two denominators, or the least common denominator. I'm going to begin with the number 5, the first denominator, and I'm going to list the first few multiples of 5, which would be 5, 10, 15, and 20. Then I'm going to take a look at our second denominator, the 3, and I'm going to list the first few multiples of 3. We have 3, 6, 9, 12, and 15. We're looking for the smallest or least multiple that they have in common. And in this case, it would be 15. So I know that 15 is going to be my new denominator, and we're going to write that down over here as my new denominator. Now, starting with 1/5, I want to change 1/5 into a fraction that has 15 as a denominator, but I can't change the value of the fraction. It has to still have the same value as 1/5. So in order to do that, I have to figure out how I'm going from 5 to 15. And in order to go from 5 to 15, I would multiply by 3. Now, in order to keep the new fraction to be equivalent to the original fraction, whatever I do to my denominator, I also have to do to my numerator. So I'm going to then multiply my numerator by 3 also, and I would get 3 as my new numerator. You may hear this reference as multiplying by the giant 1 because a fraction that has the same numerator as denominator also is equivalent to 1. This time I want to do the same thing to my fraction of 1/3. In order to go from 3 to 15 for my denominator, I would have to multiply 3 by 5. And because I also need this new fraction to be equivalent, I'm going to do the same thing to my numerator, multiplying it by 5, giving me a new numerator of 5. Because I have multiplied my fractions by the giant 1, my new fractions are equivalent to my old fractions. As you can see, the value here hasn't changed. I haven't changed the amount that I have. What I've changed is the size of the pieces, and when I chop them up into smaller pieces, I can then combine them to find my new total. When I add my numerator 3 plus 5, I get my total of 8/15. We will follow the same process when we are subtracting fractions with unlike denominators, just as we would adding fractions with unlike denominators. So here I'm going to look at the two denominators. I have the denominator 2 and I have the denominator 7. I'm going to now identify the first few multiples of 2, which are 2, 4, 6, 8, 10, 12, and 14. Now I'm going to identify the first few multiples of 7, which are 7, 14, 21, 28, and 35. If I don't come up with a common multiple at this point, then I would need to keep going. However, I can see that I have a common multiple of 14, which is going to be my new denominator, 14. So again, just like I did before, how do I get from 2 to 14? Well, I multiply by 7. And in order to make it equivalent, whatever I do to my denominator, I have to do to my numerator, giving me a new numerator of 7. Down here, in 3/7, going from 7 to 14, I would multiply 7 by 2, doing the same thing to my numerator, multiplying by 2. I would get my new numerator of 6. After finding my new fractions, I can then subtract as I normally would. So 7 minus 6 is 1, and my denominator stays the same, giving me my answer of 1/14. Now it's time for you to try one on your own. Here we have the problem of 1/6 plus 3/4. Pause the video while you find the least common denominator for each of these two fractions, change them into equivalent fractions, and then add. Unpause the video when you're ready to see the answer. Hopefully you've had a chance to solve the problem. Here, my first step was to find the least common denominator between 6 and 4. I was able to find that they had 12 as their least common denominator. When I put the 12 as my new denominator, and I changed each of the fractions into equivalent fractions, I now am adding the two fractions, 2/12 plus 9/12, giving me my answer of 11/12. Hopefully you got it correct. Let's move on and do another one. Now we're going to try subtracting. We're going to subtract 1/2 minus 2/5. Again, pause the video while you find the least common denominator, change the fractions into equivalent fractions, and then subtract. Unpause the video when you're ready to see the answer. Hopefully you had a chance to find the answer. When I was looking for my least common denominator, I listed out all of the multiples, or several of the multiples, and I found that they had the least common multiple of 10. When I use the 10 to create my two new fractions, I end up subtracting 4/10 from 5/10, and I can easily find my answer of 1/10. In this video, we learned how to add and subtract fractions with unlike denominators. Good luck!